whatever DP problems we solved, all those were done on single dimensional array. It means the memoization we applied on single dimensional array. Now we are going with two dimensional array, so it's kind of great. So let's understand the problem statement. Let me explain here. Uh, okay. Okay, so let's move on. What it is saying is you will be given a 3 by 2 m by n grid. Okay, so m by n grid. So it means 3. Assume that 3 by 2 grid. So you will be starting from so 3 by 2 grid means something like this, right? So you will be having three rows and two columns. That's it. Let me make it little cleaner. So you have three rows and two columns, 0, 1, 2, 3, and 0, 1. So there are three rows and two columns. What he's trying to say is you will be starting from 0, 0 and moving towards m minus 1 and n minus 1. So if you closely see, this is 2 by 2, 2 by 1 man. This is 2 by 1, right? So you can say that this cell is 2 by 1. So which is equivalent to m minus 1 comma n minus 1 because m equal 3, so which is 2 comma n equal 2, so which is 1. So you should start from 0 0, reach m minus 1 comma n minus 1. So you can have we need to find out unique ways to reach m by n last cell. Either you can move down or you can move right. So these are only the options we have. So that's what the problem statement says. So if you closely see here, there are constraints here. The bottom right corner, we need to reach to the bottom right corner. You can only move either down or right at any point in time. So that's a problem statement says. So let's see. So either you can move right or you can move down. Okay. So let's see what are the unique possible ways we could achieve here. So one way is this is my 3 by 3, 0, 1, 2, 0, 1. So one way is, let me copy this. Sorry. Let's see all possible ways. One way is this is one way. So I can start from here. You always start from 0 0. You can move right. Okay, I can move right. Then I can take down so that I can reach the last cell, top top bottom cell. One way is I can start from here and I can move down and I can take right and reach the last cell. This is one direction. And another way is I can start from here. I can directly come to bottom and take right. So this is another direction. So you could see that if for 3 by 2 grid, the number of unique ways, so the number of unique ways are 3. So we need to return 3, answer 3. So is the problem statement clear, everyone? Problem statement is clear. Okay, good. Maitri, is it clear for you? Okay. So let's move on. First of all, first of all, don't worry about the problem, buddy. So if you look at the problem and if you see that lines, right, you may feel confused. This is out of my knowledge. Don't worry about it. Just think in a brute force way. Just think in a brute force way. Brute force way. For example, if you closely see, let's understand what do you mean by down, what do you mean by right. Okay. So for example, I am at 0 0 index. I'm at 0 0 cell. So I am at 0 0 0 cell. So what do you mean by down to it? So it means from 0 0 cell I'll come to down, right? So you will reach to which cell, buddy? 1 comma 0 cell, right? Yes or no? The cell information is 1 comma 0. So want to see. Yeah. So you will reach to 1 from 0 0. If you come down, you will reach to 1 comma 0. So what did you understand here when you are coming down? So this is row 0 and you are reaching to row 1. It means when you, for example, you have a row comma column here. This is represented by row comma column. So to come down, so you will just increment the row. So then there is no change in the column. So it means the formula is you will just take row plus 1 comma column. So whatever row which is remaining, so plus 1 and column, there is no change in column. So that's what down is talking about. For example, from 0 0, I want to take right. Okay, nice. I want to take right. So what do you mean by, so you need to take right here, right? So what will happen? The current cell is 0 comma 1. If you closely understand, if you want to take right, there is no change in the row, but there is an increment in the column. So earlier the column number is 0, so it becomes 1, so it becomes 0 comma 1. If you consider it as a principle, there is no change in the row, there is a increment plus 1 into the column. Right, so one thing for sure, down means row plus 1 comma column. So there is no change in the column, there is a increment in the row. Right means there is no change in the row, but there is an increment in the column. Is this clear? Is this clear, buddy? Understood, or can I repeat it? So you are at 0 0 index. You are at 0 0 cell, buddy. So you are at cell number 0 0. You want to come down. Okay. So you want to come down. So how do you come down? Down means you need to switch the cell, right? So this is down direction, right? So to come to down, so what you do, the down cell is 1 comma 0, right? So from 0 0, if you want to come down, what you do, 0 0 means row is 0, column is 0. You want to come down, so what you do, you just increment the row number. So earlier row number is 0, so you see 0 0, this is 0 0, right? So row is this one is row and this one is column. So you want to come down, so to come down, what you do, you just increment the row number by 1. There is no change in the column, so that it becomes 1 comma 0. If you closely see, 1 comma 0 is the current cell, so this is 1 comma 0. So that's why if you want to consider it as a principle, from 0 0, if I want to come down, it becomes 1 comma 0. So it means when there is a row and column cell, so you just need to increment row r plus 1 comma c. So this is our down principle. Similarly, if you want to come to right from 0 0, so how do you do it? So from 0 0, if I want to come right, so if you see the right cell is 0 comma 1, how do you get this 0 comma 1? So from 0 0, there is no change in the row, there is no change in the row, but you just increment the column so that it is row comma column plus 1. So whatever column number you have, if you add plus 1, you will move to the right. Whatever row number you have, if you add plus 1, you will move to the down. Is this clear, buddy? Ajay, Maithili, is it clear? Because this is very important. Okay, good. So please respond immediately so that we can save the time. Now let's understand. Let's understand. Don't worry about anything. So you know what to do. What is the down? What is the right? Now let's move on. This is our. This is our 3 by 2 grid. Okay, so this is our 3 by 2 grid. If you closely see, this is my 3 by 2 grid. So 0, 1, 2. So what's the goal here? 0 1, so you have 3 by 2 grid. Okay, so you can say this is 0 0 0 1 1 0 1 1 2 0 2 1. So our target is 2 1. Okay, so row should be we need to reach row when row number becomes 1 and column number becomes row number becomes 2, column number becomes 1. So we are reaching bottom right cell. So let's move on. First you will start from first cell. So that's what he is saying. So you always start from 0 0 cell. So if you closely see in the problem statement also, you start from 0 0. Okay, I start from 0 0. I have two possibilities. Either I can move down or I can move right. So if I want to move down, what is the principle, buddy? This is row and this is column. So what is the principle? So row plus one comma column. If I want to move right, there is no change in the row, so you will just increment the column. So let's move on. I'll apply the same thing. So I'll move down. So it means you just need to increment the row. It becomes 1 0. If I move right, what it will become? So there is no change in the row, but there is an increment in the column. So here column is 1 0, so it becomes 1. Okay, nice. So we did one direction. So let's move further. So I want to move down. So definitely there is an increment in the row from this cell. So it is 2 comma 0. And if I want to move right, so this is down and this is right. If I want to move right, there is just increment in the column. There is no change in the row. So row becomes same, increment in the column. So 1 1. So let's do further. Let's do further. So I want to move down. So if I move down, it becomes 3 comma 0. And if I move right, it becomes 2 comma 1. Okay, if you closely see my row number 3, right? So the max row I could see is 2, but here the row number becomes out of the context, right? So the row number is greater than expected size. The maximum row number is 2, but here it is becoming 3, so that I don't need to go further. Now let's move on to right. So I can say that this is eliminated because why? Because your row number is equivalent to m, right? So this row is right. So this row is equivalent to m, so that you don't need to go further. Now let's move on. Let's move further. Now again, this is 2 1, right? So if you closely see, what do you mean by 2 1, buddy? What do you mean by 2 1? If you closely see, 2 1 is my expected target, right? Yes or no, buddy? 2 1 is my expected target or not? This is the bottom right corner, right? So that I reach 2 1. Okay, we will think about it. We will think about what to do. So I reach the expected target. So we will come to this. Now let's explore all other possibilities. Let's explore all other possibilities. In this case, 1 1 1 1, right? If you move down, definitely you will reach 2 1. But if you move right, definitely it becomes 1 2. Again, you see this 2 is right, this 2 is nothing but column, right? So the column, expected column is ideally 1, so you cannot go out of the column, right? Out of the column size. So that again, this is also can be eliminated. Why? Because the column is equivalent to n. You see, column is equivalent to n. So when column equal to n, so you can eliminate this. So done. We will come to these positive cases. First we will explore this tree. So it means you are reaching base cases to the bottom. Now let's, for the down, you are reaching all base cases. To let's move on to the right. Okay, so let me do that. So from 0 0, I just chosen down. I have seen the possibilities. From 0 0, let's go on to the right. So 0 1. Again, here also you have possibilities. You can take down or right. If you take down, it becomes 1 1. If you take right, it becomes 0 2. So obviously this is obviously out of the context because column becomes n. Okay, so column equal to n. So this is out of the context. Now let's move on. Let's move further. So this is 1 1, right? So again you have down and right. If you move down, it becomes 2 1. If you move right, it becomes 1 2. So again you see that this 1 2, this 1 2, again it is column is equal to n, so that this is out of the context. Now we have seen this 2 1. 2 1 is nothing but what, buddy? So 2 1 is our expected bottom right corner, so that you are on the bottom right corner. So it means you derived a recursive tree such that you have found all the valid cases. Now it's time for us to understand what are the paths. So let's move on. So you are here, right? So when you are here, so what we are trying to achieve here. So from a given cell, what we are trying to achieve here, from a given cell, either you can take down, either you can take right. So we need to find out all possible unique paths, right? So possible unique paths. How do you know it's a unique path, man? How do you know it's unique path? At least, at least one of the cells should not be included. That's it. So if you closely see, this is one direction and this is another direction. This is another direction. It means the repetition of the path is never been included. So all the paths are unique. So all the paths are unique. But if you cannot make any other path other than these three. If you try to make it again, it becomes duplicate. So we need to find out unique path. So simple, you move to the right, find out the path, and you move to the down, find out the path. So just the summation of down direction plus right direction, which is going to be your unique paths. So which are going to be your unique paths. So what we did is from the given direction we take down and we take right. So we need to find out summation of these two paths at each direction, then that is going to be our final result. So let's move on. What we did here, from 0 0, first I took down, and it becomes 1 0, then I down. Let me go here. So from 0 0 I took down, so it becomes 1 0. Then from 1 0 I take down, it becomes 2 0. From 2 0 I take down, it becomes 3 0. So there is no valid path, right? So there is no valid path. What should I written here? What should I written here, buddy? Can you tell me? What should I written here? 0. Obviously 0, right? Because there is no valid path. So as there is no valid path, so obviously you can return 0. Okay, so let me return 0. So this will return 0. And what should I return here? This is valid path, right? Because you are reaching the target, right? You are reaching the target. So obviously you need to return 1. Correct? Correct or not? Yes or nobody? Please. Everyone clear, right? So you reached, so that the summation of these two, so 0 plus 1, which is going to be 1. So 1 will be returned to the caller. Done. So it means from this direction, if you closely see from 0 0, oh sorry, if you closely see, so from 0 0 1 0 2 0 2 1, so you found a path. So let me check, we get it or not. So from 0 0 1 0 2 0, so see this is 0 0 1 0 2 0 2 1, so we found this path. So we already found one path. Okay, so perfect. So we got one. And let's move on the right side. Let's move on right side. Okay, so let's do that. So from here, from 1 0, you solved down path. Let's move on to the right. So once you move on to the right, from 1 0, it becomes 1 1. So from 1 0, it becomes 1 1. And from 1 1, if you take down, it becomes 2 1. It means again you reached the target. So definitely you need to return 1. Okay, so let me return 1. So this will return 1. And this 1, 2 means it is out of the context, so that definitely you return 0, because 2 is out of the column size, right? So column size expected is 1, so it is out of the column size. So that 1 plus 0, so which is going to be 1, so that the 1 1 will return 1. So it means from 1 0 you can take two directions. Okay, so if you closely see, from 1 0 I can take two directions to reach to the target. This is 1 0, right? I can take bottom and right, or I can take right and down. So that's what we did, right? So this path is talking about right and down. Okay, so it means you from 1 0, if you take down, you got one path. If you take right, you got one path. The summation of these two, which is going to be 1 plus 1, so that 2 will be returned to the caller. Okay, so 2 will be returned to the caller. It means from 0 0, if you take down, you got two paths. That's what happened, right? So this is one path and this is another path. So that's what we derived already. Now let's move. Let's move on. Let me take right. Okay, so from 0 0, if I take right, it becomes 0 1. From 0 1, if I take down, it becomes 1 1. From 1 1, if I take down, it is again becoming 2 1. It means from 0 0 0 1 1 1 2 1, it means 0 0 0 1 1 1 2 1, you find a path. So as you find a path, simply you can return 1. Okay, so let me return 1. And other direction, obviously, which is reaching out of column size, you will return 0. So the sum of this 1 plus 0, so it will return 1. And from 0 1, if you go to right, from 0 1, if you go to right, so it is out of the context, because column size is exceeding, definitely you will return 0. So the summation of 0, these two is 1 0, so it will return 1 to the caller. Now you see, from 0 0, if you take down, you got 2. If you take right, you got 1. So that the summation of these two is 2 plus 1. So this is output 3. Do you understand this, everyone? Perfect. Now, as you understood, tell me what are the base cases. So this is a mistake I did on previous session. So without taking base case, I have written the code, then you feel confused. So this is my recursive solution. So what is the base cases? What are the base cases? Tell me. First tell me what my recursive method needs. What my recursive method needs, buddy? It needs row index, column index, and what is the row size, what is the column size, correct? Yes or no? So this is my recursion method required. What are the base cases? Tell me. When are you returning 0? When are you returning 1? That is your base case. Perfect. Yeah. So when r equal to m or c equal to n, then you return what? No, no. R equal to m, c equal to n. So end of the matrix is m minus 0. But this is either of them reaching or condition here. But other base case is what? When r equal to m minus 1 and column equal to n minus 1, then you return 1. Done. That's it. So let me write the code. And what is the time complexity? Tell me. Please think about it. It's not. Don't judge it blindly, but can you think and tell me what is the time complexity? Right. So one thing for sure, for each cell we'll have two directions, right? For each cell you will have two directions, right? It means there will be two here. And how many cells we have? How many cells we have? M cross n. So let's say here 0 0 0 1 1 0 1 1 2 0 2 0 didn't come 2 0 2 1. Yeah, so definitely we'll have m cross n, right? For each cell we'll have two directions, which is going to be 2 to the power m cross n. Is it m cross n or m plus n? So let me think about it. 0 0 1 0 2 0 3 0. How many direction? 1 2 3 4 5 6 7 8 9 10 11 12. So 2 to the power 12, so which is equivalent to 3 almost. So which is m cross n means which is 6, but m plus n means which is 3. So I'm thinking it is m plus n, but I need to justify that why it is m plus n. Can anyone help me? Is it m cross n or m plus n? It's not m cross n, buddy. It is m plus n. 2 to the power m plus n. Okay, so m cross n means it should be 2 power 6. So it is around yeah, more than 64 calls, but you don't get 64 calls, right? So oddly you have approximately equivalent to 12 calls, so which is equal to m plus n. Okay, so you can spend some time on it, how it become m plus n. But for me, I am able to get the intrusion. And what is the space complexity here? What is the space complexity here? Tell me. How much of space it is occupying at any point in time? This is the only one, right? Okay, so what is that? What is that maximum length you can have? Here the max length is how much, buddy? 3, right?
Yes.
3 plus 1, so which is going to be 4. The maximum length is 3 or 4. How do you know that which is the maximum space? What is the max stack frame size? So max of m comma n only, na? Yes or no, buddy? Here m equal to 3, right? That's why you got 3. But if n equal to 5, then you will get right as 5, right? So right will increase, na? Keep on increasing, na? So that you will get right as maximum. So that obviously the space complexity, whichever is maximum, max of m comma n. Is this clear? Time and space complexities are clear? Ajay, Maithili,
Krishna, I feel it will be m plus n, right?
which one? Space complexity.
PS1, yeah.
Why, bro?
Because when it loops around it, it
It,
has to
it took
traverse from
it
0
took only
to
either
3.
of the one direction, right? It don't take both the directions at a time. So if you see, this is 0 0, right? So from 0 0 you will move on to 1, then you will move on to 2, then you will move on to 3, right? Once this is done, then you will move on to the right. Perfect.
Yeah.
You move on to the right to 1. For example, 5 something. Yeah, yeah, yes, yes, definitely it will move further. Yes, it is m plus n. Thanks, man. So his point is valid. Let's say m equal to 5, n is also 5. So what you do, 0 0 0 0, you will move 6 0, and it means you will reach 5 0, and 5 0 onwards again you will move 5 1, 5 2, 5 3, and 5 4, and so on. So then it is becoming m plus n. So that's correct. Clear? Others are clear? Others are clear on space complexity? Okay, so it is m plus n. Correct. Thanks. Let's move on. How do you write the code? Okay. This was okay. So first one is I need to find out unique paths. Unique path. So I need row, I need column, and I need I need n. So I know the base cases. So if row is equal to m or column is equal to n, so I can simply return 0. And if row is equivalent to m minus 1 and column is equivalent to n minus 1, it's trying to return 1. Now I need to find out down path. How do you find out the down path, buddy? So unique path. The down path is you just need to increment the row size. That's it. So there is no change in the column. Just increment the row size. That's it. And how do you find the right path? So from the current row, you just need to increment the columns. There is no change in the row. So column plus 1 m comma n. That's it. So finally you need to return down path plus right path. Is the code is clear? That's the code, man. Is that clear? Okay. So unique paths. Then initially starting from 0 0 m comma n. That's it. Run. So that's it. So if I submit, definitely it will give time out of bounds. Now, what is the repeated problem? Then we will just do a little change on it. Then it will work for what are the repeated problems we are solving, man? Can you tell me what are the repeated problems we are solving? First of all, how do you understand uniqueness of the problem? How do you understand uniqueness of the problem here?
If it doesn't visit the same cell twice.
Yeah, that's it, right? So from the same cell, uh, okay. So if you see here, if you already reach this cell, you know how many ways, if, for example, if you reach already this cell, so you know how many ways to reach it. You know how many ways to reach it, so you don't need to solve the same problem again and again. How do you uniquely identify the cell? How do you uniquely identify the cell number? Based on row number and
by the
column
raw
number,
ID and column ID.
row ID and column ID. If you closely see, you already solved one by one here and you got the result as one. You are trying to solve it again here. So you are trying to solve again here. So there is no need. But if you take longer size, right, definitely you will get lot of duplicate things. So in this case, you already solved one here, so you don't need to solve again here. So that's why we will have to come up with memoization. So now tell me, this is my memoization. So tell me what is the state of my memoization now. So one is row, column, m, n, and where I can store the result, buddy? Where I can store the result? I need to represent this row and column combination, right? Yes or no, buddy? Is this problem or solved or not? How can I know that? I need to represent this row and column combination. Yes or no?
Yes.
So how do I represent row and column combination?
We'll take the two-dimensional array.
That's it, right? So grid or matrix, whatever you say, so or two-dimensional array. So that's it. So that is our DP. So what is the size of my DP?
Say m comma n.
Same m comma n, right? So let me take integer DP. So this is two-dimensional array. So I'll just take new integer of m n. That's it. Done, man. So we are done with it. So now you know how do you represent that problem, and you also know is the problem is already solved. We are representing through DP. Just take a look at my code. I don't do any change. I'm introducing a new variable to avoid. Then what is the time complexity if I do that? I'm sorry. If I do that, what is the
That will
time
be
complexity?
order of m cross n.
Yes, right,
Yes,
perfect. So because we are not solving again and again, right? The same problem cannot be solved again and again. So whatever we solved here, which will not be solved again and again. So once we solve here, we don't come here. We don't come here. So you can say that if you want to talk precisely, so order of 2 into m cross n, because every cell will be visited twice. So first time it will solve, second time it is already solved, so that it won't solve again. It will definitely return the same cell, so you can ignore that 2. So it is going to be order of mn. And what is the space complexity? What is the space complexity?
Order of m cross n.
So with respect to stack and with respect to DP, so for stack again it is m plus n, and for DP which is going to be mn. So we need a DP array. So for DP array it is going to take mn, and for stack will remain same, right? So that first time all are unique. So definitely it is going to be m plus n and mn. Everyone is clear on this? Maithili, Akash.
Yeah.
Yeah.
Okay. So let's move on. So what I'm trying to do, I will use some wrapper type so that I don't need to worry about default value. So new integer of m of n. Okay. So now I am going to introduce this wrapper type here. Okay. Then what I will do, I will say if dp of initially it is null. Okay. My current row and current column, if it is not equal to null, it means I already solved it. So it's a wrapper type, right? By default, it will have null values. It is not, it is already solved. So I will just return this dp of row column. Okay. Otherwise, what I will do, I will store this, I will solve it. I will store this down path and right path here. That's it. So you can return down plus right. You can return, yeah, it's up to you. I'll just store that and I can return directly this rather than this. Clear na? Clear, right? So there is no questions on it. So while calling this mn, I will just call dp. While calling mn, I'll call dp. Here also I'll call dp. See, man, simple code. So you have to be very clean on recursive technique. Done. So you can easily submit this. Now your job is you want to convert this into tabulation. What I said, whenever you are trying to convert this into tabulation, so what is the problem here you are having, which is definitely taking this stack space, right? This is taking m plus n stack space. For example, if the m is 10 power 5 and n equals to 10 power 5, so it is going to be 10 power 10, right? So definitely it is really large stack frame. So we want to avoid this stack frame. The only way is avoiding stack frame is avoiding recursive solution, tabulation coming up with tabulation. So tabulation is nothing but what, buddy? It's a iterative solution. So it's a iterative solution. And one more thing is, in recursive solution, you don't need to worry about order of solving the problem in a order. So you don't need to worry about, you can solve the problem in any order. So you don't need to worry about order. But when it comes to iterative solution, right, you need a order of the solution. It means, for example, you are printing numbers from 1 to n. So first I becomes 1, then I becomes 2, I becomes 3, I becomes 4, something like that, right? So it means you maintain the order of elements in iterative approach, but in recursive approach, you don't worry about it. You write a piece of code, it will execute and it will give the result. So now in tabulation, you must and should know the starting point. Okay, so as I want to maintain the order of the solution, you must and should know the starting point. The starting point is nothing but starting sub-problem result. Okay, so starting sub-problem result. So you must and should know starting sub-problem results. The starting sub-problem results you can pick up from pick it up from memoization approach. Okay, so pick up from what is it? Recursion solution, recursive solution. So what is the subproblem result you could see on the recursive solution? Tell me, buddy. What is the subproblem result you could see, valid result you could see on recursive solution? Line number 11, right? So this is your result, right? Yes or no, buddy? That is your result, correct? Yes, Ajay, Maithili, Akash. Okay. So nice. So that is our subproblem result, right? So it means I need to start tabulation solution from there. I need to start tabulation from solution from there. It means if you closely see, if you closely see, so this is my, I don't want to write this table, but for the first time I will do it. Or I'll write this table once we convert this code into tab. Otherwise, you will, okay, I didn't share. Otherwise, you will focus on this table that I don't want to do it. So for sure, uh, so see, look at the screen carefully. So this is my DP. Initially, everything is zero. And what I'm doing, I know the subproblem solution, right? So which is from recursive. So when DP equal to m minus 1, a row becomes m minus 1 and column becomes n minus 1, then you will make the value as 1. Okay, now you have to solve this problem from the bottom. So actually we have solved from the problem from top, right? So top 0 to 0 to m minus 1 to n minus 1. But this is bottom. So this is m minus 1 and n minus 1 is the bottom, right now, buddy? So this is bottom up approach, na? This is bottom up approach. So you have to solve this problem from bottom. So that's how you solve it. Then that's how you solve it. So let's see how can we do that. So let's see how can we do that. Simple. So I want to solve this problem from bottom, right? So definitely I am going to take integer row equal to m minus 1 bottom, right? So bottom up approach. So row greater than or equal to 0. This is only the difference, buddy. So how the reverse of the equation, that's it. So not the equation, the reverse of the initialization of the variables, that is going to be your tabulation approach. Okay. First of all, this line is clear. So I should do minus minus. Is this line is clear, everyone? If this line is clear, line number 629. Maithili, are you clear on it?
Yeah, sure.
Yeah. So it's a bottom-up approach, right? So because why I'm stressing it, if you solve this problem, then remaining problems becomes easy. So don't mind it. Okay, nice. So you have row column. Now again go to the same principle. So for example, you write a base case if down, right? So it means if you are into last row, if you are into last row, how do you know last row? If row equal to m minus 1 and column equal to n minus 1, which you already solved it. So that don't solve it again. So that just continue. Just continue. Okay. Now let's move on. Let's take again same thing. So you need two variables, right? So just go for it. So down path. I will optimize this. First you will understand. I'm just taking the same code and converting into tabulation. Uh, it's a different way of writing the code. That's it. So down path, up path, right? So when do you move down, buddy? When do you move down? Whenever your row plus one, if it is less than m, then you move down, right? Yes or no, buddy? Yes or no? So how do you know the down path? So you just need to, you already solved, right? So whenever row plus one equal less than m, you already solved it. That is present in dp of row plus one comma column. So it is a bottom-up approach, right? It is a bottom-up approach. For example, if you closely see here, you are here, buddy. Let's say you are here. So you are trying to take down. So you are trying to take down. So this is 2 1, right? Assume that this is what do you call 0 1 2. Okay, 0 1 2. Let's say it is 2 2. So definitely it is 0 1 2, right? So it is going to be 1 comma 2. So from 1 comma 2, if you take down, you have 2 2. So it's a bottom up approach, right? You already have value in this. So in a bottom up approach, we already replaced this top bottom value with 1. So you already know the result of the problem already. So you already know the problem. So you just take that row plus 1 commas column value and add to the down path. Similarly, this is down. And similarly, when do you take right, buddy? When do you take right? Same logic, right? So I'm not doing anything. So whenever your column plus 1, so which is less than n, then you will take right. So you will take right, right? So when you take right, so just take right path. So right path value is already been solved. So you can simply say dp of row, comma, column plus 1. That's it. So it means if now you find the down path, you find the right path, and the now the current row column value, the current row column value becomes down path plus right path. So we didn't do anything new. So earlier we have did row plus one comma colon. We try to solve that result. We try to solve that result because we didn't know that. But in this course, in bottom-up approach, we already know row plus one column. When you are into current row column, when you are into current row column, the next columns is already been solved because we are doing backtracking, right? So from bottom up. So when you are at row 2 1, you already solved row 2 2 and row 3 1 and all. That's why you just need to take that result, store here, and the current row column becomes down path and right path. So finally you will just get it. So finally at dp of 0 0, you will have the result. So just return that result. Understood, buddy? Understood? It's a it's purely bottom up, right? So it means from m minus 1 to n minus 1, we just reached to the top. What it is saying, column is not defined. So if you submit, that's it. So don't ever write. So don't ever, if you precisely speak. So ideally, you should copy this code. Ideally, this is how you should do it. You copy this code. Okay, so int down path and right path, right? So I already defined it. So just move this. So this is right. So this is earlier you don't know this problem. So that now it's a bottom up, right? You already solved this problem. This row plus one and column plus one. So just replace dp of row plus one, comma colon. These are only the unique problems, right? Similarly, take other row, other thing also. This is row column plus one, right? So dp of row and column plus one. Don't think anything. So just blindly solve this. Just a second. Yeah. So ideally, what we did is earlier we have a conditions here. So we have 28 condition, right? So that we need to replicate here. That's it. So you know that's what we did. So if row plus one less than m, you do it. Similarly, if column plus one less than n, you do it. So that's it. So this will simply, so you, if you closely see, we have just copy pasted the recursive solution and just updated it. So if you run it, so same things. Earlier I just explained it. I just did it. Now if you closely see, you can improve this logic. The submission rate is around 6%, right? But how do you improve this? So simple. Uh, you can avoid all these things. Uh, you can avoid all these things. If you closely see, I'm just removing this. If row plus one less than m, I'll just add that value to the DP. And similarly, if column plus one less than n, I'll add that value to the DP. So I can avoid this. So now if I run it and submit it, so it went into 100%. So it's simply about optimization of the code. Don't worry about optimizing the code. Uh, just uh, just take the memoization solution, try to update it, then you can still further optimize it. You can handle through single dimensional array. Okay, let you explore on it. Probably for other problems I will talk about it, but if I include everything on single problem, it will be heavy. Okay, so now let's understand what how it is working. Let's understand how tabulation is working so that so we already know, we don't know how tabulation works, but we just copied and pasted the memoization logic, right? So let's understand how it works. Who is trying to join? What's happening? Host management, turn on video, turn on microphone. Let contribute, send messages. Okay. So let's move on. So you have three columns, right? So this is what it happened, right? So 0, 1, 2, and 2 rows, right? So let's move on. Three rows and two columns. So we made this as one. So what we did, so we just took this value. For this one, we just take this value, it becomes one. For this one also, we just take this value, it becomes one. For this cell, the sum of this one and sum of this one, so which is going to be 1 plus 1, so which is equal to 2. And for this cell, obviously the down, from down you get 2, and from this you from down again you get 2. So for this cell, down you have 2, and right you have 1, so 2 plus 1, which is equal to 3. That's how it is working. Is this clear, buddy? Is this clear? Okay, let me, did I went fast? People will come up with this table and try to explain it, so that's not the right way. What happened, man? Okay. So simple. So here you can't take right, so that it becomes 0, and down it becomes 1. So 0 plus 1 1. From here you can take right, but you can't take 0 down. So it is 0 plus 1, so it becomes 1. From here you can take both and right, so 1 plus 1, which is 2. And here you can take only down, so which is 1. So from here you can take both right and down, so 2 plus 1, which is 3. So that's it. Okay. Let's move on. Yes, Ajay, tell me.
Shinu, by the way, during the interview, when they ask a question, they will not expect us to explain recursive tabulation, everything. They would expect us to give the right answer. So, is it practically possible to get the optimized solution in one go without us seeing the problem before or practicing at least once? Because if you see a new
Yeah,
problem, I don't think it's practically possible to go to the optimized one in a single shot.
correct. So definitely you should not go with the tabulation for sure in interview.
Okay.
First you should, if you are very confident, you can directly write the memoization. Okay,
Okay.
so that's it. If he is fine, you can done with it. So you don't need to worry about the tabulation also. But if you want, you can I can convert this into tabulation. Just copy and do paste, same code. Okay,
Okay.
so but they will
Is it
expect.
okay if we can think of recursive solution and explain it? Are they will they be okay with it, or they would expect at least memorization?
It depends on the level of interview you are giving. If you are giving for L4, then if it is super intuitive, they are happy with recursive solution. Uh,
Okay,
but yeah, if you are giving into L5 and L6, then definitely they will look for optimized ones.
got
So
it. Okay,
it all depends. Okay, that's it. So yeah, we are done with this. Now let's understand this. Shall we continue this? Yeah, we have 15 minutes left, right? So let's continue on it. Just a second. So I'll give you the recursive solution for it, so that you can convert this into memoization and tabulation. Let's see how it works. Okay. Uh, so the problem statement is more or like similar, but it needs more infusion to solve it. Let's understand how it works. Let me take the, so you have grid 131, 151, 421. So this is your grid. So what he's trying to say is, same problem is same. So it's a m by n grid, non-negative numbers. Find a top left to bottom right, which minimize the sum of all numbers along its path. Note you can only move either down or right. So what he's trying to say is, this is our grid. Okay, so this is our grid. So we need to start from 0 and move to the bottom. We need to start from 0, move to the bottom, and we need to find out sum of all the cells. Return the minimum cell. For example, if I take this direction, there are multiple directions, but let me take one or two. It is 3 by 3, right? You will get lot of directions. Prior to that, let me copy this. Okay. So let's see here. For one direction could be, let me take one direction. So one direction could be I start from here and I can take to the bottom. If you closely see all sum, right? So I need to consider all the sum 1 plus 3 plus 1 plus 1 plus 1. That's it, right? So 3 plus 4, which is equal to 7. And one direction is I can start from, I take right, then I can take down, then I can take right, then I can take down. So definitely the sum here could be 5 plus 3, which is going to be 8. And other direction is I can take complete right and take down, take complete down, take right. So it is going to be something 10 plus 2, 12. So like that you will have lot of other options. So this is the best possible solution. We need to return minimal sum. So the minimal sum is 7, so which is to be returned. So either you can move, you can take down or you can take right at any point in time. So is this clear, buddy? Is this clear? Problem statement is clear. Okay, so let me take somewhat minimal thing. So let's go to our favorite size, which is 3 by 2. Let me take somewhat, you have three rows, 0, 1, 2, two columns. Let's say I have 3, 2, 1, 1, yeah, 2, 1. So let's see what is the possible, if you closely see, I can easily write the directions for this as we already discussed about it. Okay. So one path is what? One path is this one, definitely which is value 7. One path is this one, the value is 6. Other path is this one, the value is, let me take this as value is 6. So you can return minimum value out of it. So the output definitely it is 6. Okay. What is the value here? It is not 6, right? It is 6, sorry, is 7, right? So obviously the expected output will be 6. So this is what the expected output. Now let's understand there is no change. There is no change, but don't get worried about it. So same problem, right? So let's understand. Let's write a recursive tree. Then we will try to figure out a possible ways. So 0, 0. This is down and this is right. So definitely down 1, 0. Again down 2, 0. Again down 3, 0. So obviously this will be invalid. Then let me move a little up. Okay. So again it is 2, 1 and 3, 1. I think you reached already, right? 2, 1 means it is end of the cell. So this is 2, 1, right? So it is 2, 1. Okay. So let's move on. 1, 1, 2, 1, 1, 2. And I'm directly writing it because it is already discussed problem. So I don't want to waste time here. Okay. So now you understand that this is the cell number 2 comma 1, right? So this is cell number 2 comma 1. So these all are 3 0 and 1 2 0 2. Here also 1 2. These all are invalid because C becomes N. Here also C becomes N. Here also C becomes N, and here R becomes M. So we are invalid. Now now we have written a tree, right? This is very critical, buddy. So this whatever thought we are going to apply, this is the key to this problem. So everything is similar. Whatever thought we are trying to apply, which is the key to the problem. So let's understand. First we will start from 0. Okay, so we'll start from 0. So 0 is having value 3. From 0, I can take either left or right. I need to find out whichever is minimum out of these two. So from 0, I can take left down or right. So whichever is minimum out of down or right, I need to solve it. So let's first solve down. Are you following me? So I am starting from 0, right? I am starting from 0. So that for 0 value, because you are considering all the values, right? In this case, what you did, 3 plus 2 plus 1 plus 1. And in this case, you are considering 3 plus 1 plus 1 plus 1. Here, 3 plus 1 plus 2 plus 1. So you are considering all the values. But here, the decision we are trying to make is from this direction, I can take two direction. From 0, I can take right or I can take down. But answer is presented on the down. Because why it is presented on the down? Because when you move on to the down, you get a minimum value. So that what you should do is from the three, I need to take either down or right. I need to find out whichever is minimum from down to right, or either down or right. I need to find out whichever is minimum. First, let's solve down. So if I take down, I'll get 1 comma 0. At 1 comma 0, this is 0, right? 0 1. So this is 1 comma 0. This is 1 comma 0. So this is 2 comma 0. Hope you are able to follow me. 1 comma 1, 2 comma 1, 0 comma 1, 0 comma 0. Okay, so let's move on. So at 1 comma 0, so this is 1 comma 0, right? So at 1 comma 0, you have value 1. Okay, 1 plus, find out minimum of these two. So from again, we need to find out min of down comma right. Okay, so down and right. So whatever minimum. So let's move further. So if I go here, if I take down, so let me solve this direction. If I take down, I'll go to 2 comma 0. At 2 comma 0, you have value 2. Okay, so 2 plus, find out minimum of these two. If I go further down, which is going to be what, buddy? Which is going to be what? So from 2 comma 0, if I go to 3 comma 0, so which is my negative case, right? Yes or no? Negative case. So what should I return now?
Yes.
What should I return now?
Zero. Zero.
If you return 0, that is going to minimum, right?
Yes. So
You need
the
you need
minimum.
you need to this is going to be, this should not, this should, if you return 0, right, that value is going to be minimum. We want to find out minimum on down comma right, right? We need to return max value, correct? So int dot max.
Yes. So whatever the value is present there, that one, comma, the what are the upcoming values there? Max of these two values.
No, generally what are you trying to? So when you are reaching 30, right? From 30, what you should return? You should return integer dot max value because
Okay.
you need to find out minimum of down comma right, right? For this.
Yes.
So if you
Correct.
return
Correct.
max, it always going to be invalid. That's what I'm trying to say. Okay.
Got it.
So this 30, when you find invalid result, return max 2 comma 1. You already reached the end, right? Return that value. So 2 comma 1, for 2 comma 1 you can return 1. For 3 comma 0 you can return integer dot max. What is the minimum out of max comma 1? Definitely 1, right? Yes or nobody?
Yes.
So definitely
Yes.
1. So 2 plus 1, so 3 will be returned here. So this will return, this 2 comma 0 will return 3 to the caller. It means from 1 0, if you take down, you will reach 2 0. 2 0, you have value 2. 2 plus, and what is the minimum value for its subcalls? It is 1. So 2 plus 1. So from 2 0, you will return 3 to 1 0. It means from 1 0, from 1 0, if you take down, definitely you will get 3. So from 1 0, if I take down, I don't have any option, right? So 1 0, I take down 2 plus 1, so which is going to be 3. So we got 3. Now we found one value. Now let's, it is a down, right? So now let's find out right result. So you are at 1 1. So closely observe, don't get confused. You are at 1 comma 1. So at 1 1, what is the value you have? 1. Okay, 1 plus minimum of these two. So 2 1 definitely will return what, buddy? Let me take different color. So 2 1
Integer dot
definitely will return
max.
2 1. 2 1 is valid, right? 2
Two one
1
is
is
valid.
valid.
Yeah.
So it
One.
will return 1. But 1 2 is invalid, right? So 1 2 is invalid because it is reaching out of the column size. So it is returning max. So it means out of these two, so 1 comma max, what is the minimum? So we need to find out minimum out 1 comma max, which is 1. So that 1 plus 1, which is going to 2. So it will return 2. If you closely see, from if I take down, I took 3, I get 3. If I take right, I get 2. So that I need to find out minimum of these two. So obviously, minimum of d comma r, right? So minimum of 3 comma 2 with respect to 1 0. So which is going to be 2. So at 1 plus 2, so it is going to take 3. It is going to return 3. Understood? Understood, buddy, please. Or got confused? No confusion. Good. So you return 3. Now it means from 0 0, if I take down, I got 3 as the minimum result. So if you closely see, that's what happening here. From 0 0, if I take down and right and down, so the optimistic minimum result I could get is 3. The optimistic result I could get is 3. So we found that result. Now let's move on to the right. So from 0 0, if you move on to the right, okay, so I move on to the right. So I go to 0 1. Okay, so 0 1. At 0 1, what is the value you have, buddy? 2, right? So just take 2. Plus find out minimum of these two. So obviously 1 1. So if you go down, you will reach to 1 1. 1 1 will have 1. And plus either you reach 2 1 or 1 2. So 1 2 will return max value and 2 1 will return value 1. Out of these two, minimum is 1. So it is going to be 2. So that 1 1 will return 2 here. Now 0 2, definitely it will return max here. So out of these two, the minimum is 2. So 2 plus 2, which is going to be 4. So 4 will be returned here. Out of 3 comma 4, the minimum value is 3. So that you just take 3 and 3 plus 3, so which is 4, sorry, which is 6. 3 plus 3, which is 6. So this is your expected answer. Clear, buddy? Clear?
Yes.
Kalyan, Akash. If you,
Yes.
yeah, if you lose the focus, then we will confuse. So what is the time complexity? Same, Naban. So space complexity, same, right? There is no change. Okay, right. So just now, let's write that brute force. Uh, I'll write the brute force. You apply tabulation and memoization on it. If you feel like complex, then we will discuss that tomorrow. So integer min path sum. So this is my integer grid, integer row, integer column. I can derive yum n from this grid, so I don't need to worry about it. Or you want it? Okay, int n. So what are we doing here? So if you closely see, what are we doing here, buddy? So same thing, right? So let me close this. Oh, okay, you are there, right? Okay. So same thing. So when your row is equal to yum or your column is equal to n, then you need to return integer dot max value. So this is the base case, right? And what is other case? So when your row equal to m minus 1 and column is equal to n minus 1, then it's time to return that grid of row minus 1, column minus 1, or row column, whatever it is. I return this because it will be easy for you to write the tabulation. Okay, nice. So next, what is the next job? So we need to find out down path. How do you find out the down path? So min path of sum, this is our grid, row plus 1 comma colon and n, and we also need to find out right path. So for right path, there is no change in row and there is a change in column. Then what are we doing? What are we doing, buddy? This is more critical. So what are we doing? We are taking the current value. That's what it, right? So we are taking the current value, which is row comma colon. To this current value, we are considering what is the minimum value out of this down path and right path. What's happening? Understood, buddy?
Srinu, one doubt.
Mm.
In line number 9, we are doing grid of row minus 1, column minus 1 to go to that particular value. But in line number 14, we are doing directly row or column.
No, no, this is the what we did. If you closely see, what we did first, we take the current value, right?
Yes.
3 plus minimum of down path and right path, right?
Yeah.
So it means this is a base case, right? Whenever your row becomes m minus 1, column becomes n minus 1, you blindly return the value present in it, right? Array,
Yes.
this one is not the one we written earlier. This is a value present in it.
Yes, the value present in it.
Mm,
But in 14th number line, right, when you're assigning it back,
mm.
yeah, that one grid of row and column. Why we're doing row column? Why not row minus 1, column minus 1?
I got your doubt, so let me clarify that.
I mean, it might work,
No, no, no.
but
It will
still,
not work,
what?
right? So, for example, you are at, assume that you are 3 by 2 matrix. You are at,
Mhm.
mm, what is it? You are at 1 comma 2, okay? Or 1 comma 0, or 2 comma 0. Let's say 2 comma 0. So, if you take down, it is becoming 3 comma 0. If you take right, it becomes 2 comma 1. Assume that 2 comma 0 cell value is 4. So you will consider 4 plus you reach the base case now. 2 1 is your base case, right? In our case.
Yes.
So 2
Yeah.
1 is base case. So from here, from current row 0, it means from 2, this is row, this is column. This is what? Row plus 1 comma column. This is what? Row comma column plus 1. Okay? To with
Yeah.
respect to this. With respect to this, right? So from here, when you can't divide it furthermore, right?
Correct.
So when you reach the base case, when you reach the base case, you return the value to parent. You don't derive it. So this is my parent, right? From parent row 0, I am deriving it. So you return a value, whatever value present here. For example, 5 is present, return 5. So this is invalid case, you return max. Out of this, you consider min and consider that. So 4 plus 5, which is going to be 9. What is your doubt here? What is your doubt? For example, if I can't start furthermore, right? From 2 1 I can't start. How do you get row minus 1 and column minus 1? Throughout the recursion, what we have done. So we consider current row value, then that is 3 here 003. Then we took down and right. So for which what is the minimum value we got, that is added, right?
Correct. Yes.
Mm. There is no point of adding row minus 1. And how do you, for example, if you are adding, what is this recursion call is representing? From this current row, from this current column, if you take down, if you take right, you will get the minimum value. That minimum value add to this current cell.
All right. Yeah. Got it. Yeah. So basically, whatever the node we have, for that node, we are calculating what will be the
Yes,
minimum
yes, that's
values
what. Yeah,
in
that's what,
numbers.
right? So
Okay.
you can't do that. So finally you can return min path sum. Others are clear. Where is it? Others are clear on it. Akash.
Yeah, it's clear.
So min path sum from this grid, row 0, column 0, and grid dot length is m, grid of 0 dot length is m. That's it. Let's run. There is a mistake. Let me look at that. Down path, right path, fine. Array man, it should not be row. Array, it should be m minus 1 and n minus 1, right? Yeah, I understand why you. It should be last row, right? You can say it's a mistake on the coding, man. It's a between row column, right? I got your doubt. I didn't see that line, Ajay. So when you reach the last cell, you just need to return that last cell value, right?
Correct.
Yes, yes.
Yes.
So actually, I thought of writing. m minus 1 comma n minus 1. I did a mistake on row column, so that's
Row
why,
minus. Okay.
yeah. So actually it should be m minus 1 comma n minus 1, or you can have row column. Okay, so then it will work. I didn't see that. I have written a, there is some extra this. So now let me quickly, now you understand the duplicate problems again, right? Where is the duplicate problem, buddy? Same thing, right? Same problem, na? Do you try it, or can I write it the memorization and you will write a tabulation?
We will try it.
You will try it, okay. So if you close this is
Mhm.
duplicate problem, na? So this is duplicate
Yeah,
problem.
just like the previous one, this is a duplicate problem.
Yeah. Just like previous problem, try memorization and write tabulation for it. Okay. So while writing the tabulation, blindly follow memorization and implement it. Then then later you can optimize the tabulation. Okay. That's it. So please practice. So we can improve the progress if you practice. So that there are a lot of problems, right? But the thing is, all the DP problems, right? If you don't write that recursion tree, na, you are gone. You can't get any thought. So you have to be very clear about, you have to be very clear about the base cases we write, and yeah, the base cases we write and the solution you derive. Line number 14, right? You know, let me stop.